This video presents some solutions to example problems from the time, distance, and acceleration problem set from the scienceprimer.com. I pulled this question right out of the problem set, and when I loaded the page, the question I got was, I was asked to, given that the acceleration due to gravity on the moon is 1.6 meters per second squared, we're asked to calculate the distance an object will fall in 11.7 seconds. So we're given an acceleration due to gravity, and we're given a time the object fell, and we're asked to find the distance. So the relationship we're looking at here is we're asked to find the distance given acceleration and time. Now the relationship solved for time here is actually distance equals the acceleration due to gravity times the time squared divided by 2. Before I go ahead and use this to solve this problem, I want to talk about the general structure of this problem set, because as with a lot of these relationships where you're given the relationship between three parameters, it's important to be comfortable to manipulate this. So if you're asked to find distance, this is the formula you can use. The distance equals the acceleration due to gravity times time squared over 2. But you may also in this problem set be asked to find acceleration or time. And so it's important to be able to solve for any one of these variables if given the other two. So let's go ahead and manipulate the equation. Distance equals, starting with the one we're given, over 2. To solve for acceleration, first we multiply both sides by 2. End up with 2 times the distance equals acceleration divided by times t squared. Now we can divide both sides by t squared, time squared. Time squareds cancel here, and we end up with acceleration equals 2d over t squared. So if you're asked to find acceleration given a distance and a time, this is the relationship you need to be able to find. And then finally, if you are given acceleration and distance and asked to find time, we'll go back and start with this relationship again. So if we start with distance equals acceleration over time squared divided by 2, we'll do the same thing again. We'll multiply both sides by 2. The 2's cancel. We end up with acceleration times time squared equals 2d. And now we divide both sides by acceleration. We end up with t squared equals 2d over acceleration, because these accelerations cancel. And now the final thing we have to do is to get rid of this t squared, we have to take the square root of both sides. And we end up with t. So the square root cancels out that t, so we end up with t equals 2d over acceleration square root. So these are the three forms of the equation you're going to need to be able to find in order to solve the problems in this problem set. So now that we've done that, we can clear the screen and focus on this specific problem. Again, the relationship we're looking at here is distance equals acceleration times time squared divided by 2. Go ahead and put the numbers into the problem. Acceleration is 1.6 meters per second squared times 11.7 seconds squared divided by 2. Pull the calculator over. 1.6 times 11.7 squared divided by 2 equals 109.5. So the answer here is 109.5. And now let's just check the units. So I'm going to pull these units out. What we did here was we have a meters per second squared and a seconds squared. So we have meters per second squared times seconds squared. The seconds squareds will cancel and we end up with meters, which, since we're looking for distance, is the unit we want, so this is the answer. And solving for units allowed us to confirm that we actually found the number we found was in the units we were looking for. Let's go ahead and clear this. Try one more. Reloaded the page after solving that problem and I got this question. Given that acceleration due to gravity on Mercury is 3.7 meters per second squared, calculate the time it takes for an object to fall 196.3 meters. So this is the same type of question, but you'll notice the relationship is different. We're still given the acceleration due to gravity, but now we're also given distance and asked to find time. So this is one of the other relationships. We have to solve the equation for time, and I did that in a previous page, so I'll just write it here. Time equals the square root of 2d over acceleration. Put the numbers in. We have 2 times 196.3 meters over 3.7 meters per second squared. And this whole thing, we take the square root of this whole thing. So let's deal with the numbers and the units separately, but I will solve for units again just to make sure that what we did makes sense and we get the proper units, which again is a very good way to make sure that your relationships, the manipulations you did with the variables, are appropriate, because if you did it right, you should always end up with the units you were looking for. So 2 times 196.3 divided by 3.7, we'll stop there, equals 106.1, and then we need to take the square root of that, and we end up with 10.3. So the numerical answer on this one is 10.3. So now let's check units, and units is a little bit, so we have meters divided by meters per second squared, and we need to take the square root of this whole thing. Meters divided by meters per second squared is the same as saying meters times seconds squared divided by meters. We just flip this around to get it out of the denominator, and in this format the meters cancel and we end up with seconds squared. So we end up with this square root, because we haven't dealt with the square root yet, we end up with square root of seconds squared. This goes away, and the units we get, the cancel, squared, square root of something that's squared equals itself. So we end up with the units of seconds. So the answer to this problem is 10.3 seconds. We were asked to find time. We ended up with seconds, so we can be fairly confident that this is the correct answer.